Hello everyone, this is Mingshen from TikTok. Today I'm going to present TikTok's open source privacy innovations. TikTok privacy innovation was launched in 2023, which is one of TikTok's open source initiative committed to advancing data privacy through cutting-edge technological advancements like privacy-enhancing technologies. Since launched, we have open-sourced 6 projects under the Privacy Innovation Initiative, covering almost all domains of privacy-enhancing technologies. Before we dive into these contributions, let me briefly introduce what is privacy-enhancing technology. Privacy-enhancing technology, PET, is a set of advanced privacy and security techniques designed to protect personal and sensitive data while enabling data analysis, sharing, and collaboration. Some of these emerging technologies are often mentioned while discussing PETs, that are synthetic data generation, differential privacy, secure multi-party computation, anonymization, pseudonymization, confidential computing, trusted execution environment, and federated learning. To give you a concrete example, differential privacy is a property of a dataset or database, providing a formal mathematical guarantee about individuals' privacy. Differential privacy generates anonymized statistics in the dataset, and this is usually done by randomizing the computation process that adds noise to the output. Based on the foundation of privacy-enhancing technologies, we have open-sourced several projects to accelerate PET adoptions in the wider community. GitHub TikTok Privacy Innovation is our main repository to host and maintain our open-source projects. Feel free to check it out in this link, github.com/tiktok-privacy-innovation. I'll briefly go through the key projects in the repositories. The first project is called Privacy Go, which is a project aiming to combine different PETs for better privacy guarantees. There are multiple sub-projects in this repository. DPCA-PSI, which is a protocol for computing intersection-related statistics from private datasets while reducing privacy leakage. Privacy-preserving ads measurements, PPAM, leveraging DPCA-PSI enables private ad measurement, offering advertisers ability to measure the effectiveness of their ads while ensuring user privacy protection. MPC Dual DP is a distributed protocol for generating shared differential privacy noise in a tool-serving setting. MPC Dual DP leverages MPC to sample random noise according to specific distributions and outputs the noise in the form of secret sharing. Null PSI offers a framework for systematically assessing the privacy of intersection sites revealing PSI protocols by employing carefully designed site membership inference attacks. It enables an adversary to infer whether a targeted individual is in the intersection, which is also known as a membership information. The last one is called GCMS-OCMS. We propose a generalized count mean sketch GCMS protocol that captures many existing frequency estimation protocols. Our method significantly improves the three-way trade-offs between communications, privacy, and accuracy. We also introduced a general utility analysis framework that enables optimizing parameters designs. Based on that, we propose optimal count mean sketch OCMS frameworks that minimizes the variance of collecting items with staggered frequencies. However, we present a novel protocol for collecting data within unknown domain, as our frequency estimation protocols only work effectively with known data domain. The second project I want to mention today is called PET-ACE, which is a framework for privacy-preserving computing. It provides strong privacy guarantee by analyzing and computing cryptographically pseudonymized data without revealing hidden sensitive information. It consists of the following parts. First, the user interface layer provides users with high-level programming interfaces for collaborative data analysis, like secure NumPy, joint SQL query, secure SQL, and privacy-preserving machine learning, secure ML. It also supports large-scale dataset computing by combining secure multi-party computation and parallel processing systems, such as Spark. The virtual machine layer is responsible for passing high-level language into secure multi-party computation operators and performing automatic optimizations and scheduling. The protocol layer includes secure multi-party computation protocols such as general-purpose two-party secure computation protocols, private set intersection, and private information retrieval. The primitive layer consists of standard cryptographic algorithms and protocols, differential privacy mechanisms, and abstract network interfaces. The next project in the open source is shadowgraphy. Shadowgraphy is a collection of cryptographic pseudonymization techniques implemented in C and C++ and wrapped in Go language. Shadowgraphy implements FF1 specified in the NIST standard. Now let's look at another project called Trustless Attestation Verification. Remote attestation services introduces a new problem by expanding the trust boundary of TEE. Ideally, relying parties would only need to trust hardware vendors to correctly implement the TEE. However, they now must also trust the remote attestation service. Well, this may not be a significant issue for the most of the time, since remote attestation service providers like cloud service providers are generally trustworthy. But some cases are still occur. For instance, remote attestation service might become buggy after version update. Additionally, attackers may have border attack surface. This project aims to eliminate the need for a trusted third party by utilizing zero-knowledge proofs to create a trustless attestation service. By leveraging zero-knowledge proofs, the attestation service can demonstrate to relying parties that the attestation process is correctly executed. This ensures the integrity of the attestation process, reduces attack surface, and maintains a minimal trust boundary. In this particular scenario, we don't actually need the scheme to be zero knowledge because the inputs to the remote attestation service, that is, the evidence provided by TEE, are meant to be transparent and public accessible. What we require from zero knowledge proofs is their ability to demonstrate that the attestation process is executed correctly as expected. You can learn more details from the website. The next open source project is called PET Platform, which is one-stop solution builder for integrating privacy-enhancing technologies on a large-scale dataset, which offers distributed task management and modular implementation. The whole system consists of 4 key sub-modules. First, PET Platform. PET Platform serves as the main repository of the project and is also a service for job management and scheduling. It is responsible for coordinating and overseeing the operation of other 3 modules. Second, PET-ML. PET-ML is a machine learning framework based on multi-party computation and federated learning. PET-SQL. PET-SQL is a data analysis framework based on secure multi-party computations. Last one is PET-NAT. PET-NAT is a lightweight data proxy gateway which supports real-time data exchange between parties. PET platform provides a comprehensive suite of privacy computing features, allowing users to perform a wide range of tasks. Here are the key features provided by PET platform. Private set intersection, SQL on privacy-preserving datasets, privacy-preserving XGBoost classifier and regressor, XGBoost classifier prediction and regressor prediction, latent algorithm for community detection. The last project I want to introduce in this talk is called Manatee. Manatee is an open source framework for secure data analytics in public research. It leverages privacy-enhancing technologies, including confidential computing, to protect sensitive data while maintaining usability. Manatee project was initiated in 2024 as a core use case of TikTok. Now part of Confidential Computing Consortium, Manatee addresses the growing challenges of balancing privacy, usability, and accuracy in data collaboration. Manatee introduces a two-stage data clean room model to provide an interactive interface for exploring data while protecting private data during processing. It combines different privacy-enhancing technologies across two stages. The first stage, programming stage. Data consumer explore datasets using low-risk data, employing different PETs such as pseudonymization or differential private synthetic data generation. The second stage, called secured execution stage, workloads run in the trusted execution environment, which provides a testable integrity and confidentiality guarantees for the workload in the cloud. Some of the potential use cases for Manatee include Trusted Research Environment, TRE, which is a use case to secure data analysis for public health, economics, and more, while maintaining data privacy. Advertising and marketing, lookalike segment analysis, and private ad tracking without compromising user data. Machine learning, Manatee can enable verifiable private model evaluation. As you can see, we contributed a lot in the open source community. In addition to these contributions, we also work closely with PET community to share our experiences and drive PET adoptions. Notably, we joined as premier member of Linux Foundation Confidential Computing Consortium to drive innovations in confidential computing started from 2024. In OpenDB community, we also share our experience of applying differential privacy in the community meeting. We also actively engage with academic community to inspire research and novel methodologies and solutions in applying privacy-enhancing technologies. In the end, I want to emphasize our main theme. As you can see from the introduction, we contributed a lot of open source projects and engaged with the community. Therefore, it demonstrates our love to privacy-enhancing technologies. From launching TikTok privacy innovation to open sourcing contributions in PET fusions, privacy-preserving computing, pseudonymization, zero-knowledge proofs, trust execution environment, as well as actively participate community engagements and activities. These all showcase our long-term commitments in privacy-enhancing technologies and the open source community. That's all about today's talk. Thanks for your time.